Okay, GS 142. I'm back to do a much shorter recording on part 2 of the Running Water Lab 6. So let's go to the page with the questions on it. Okay, so this is worth 9 points of the 30 points total for this Running Water Lab. I've showed you places in Google Earth, and you should answer each of the questions for those different spots. For this part of the lab, you'll be entering your answers into Moodle as you've been doing for previous labs in a quiz format. Okay, so here we have 1A. I'm not sure why I called it 1A when that's 2 there. So here we are in the Canyonlands National Park in Utah. In this view, from Grand View Point in Canyonlands National Park, the 2 yellow arrows indicated stream branches that are experiencing headward erosion. Headward erosion allows streams to lengthen in the upstream direction. As seen from this viewpoint, in which direction, right or left, are the streams lengthening? Notice the north on the N on the circle in the upper right of the photo. So up here on this photo, notice that N is pointing down, which means that we are looking from the north towards the south when we are looking at this landscape here, okay? So this is the low area here. See that you can see the stream. Now, they don't have anything in them right now. It doesn't look like. These are ephemeral streams. You can see how they've cut into this landscape here. And then this is Green River, I think. Okay, I mean, it certainly looks green, doesn't it? But Green River goes down out of Colorado and across the eastern part of Utah and then out the south to become meet up with the Colorado. So if we're thinking about which direction they're eroding into as they're doing headward erosion, that means the top of the stream, the highest part of the stream, okay? So if north is to the bottom, then which direction are they eroding? So north is down, and they are eroding like what, 45 or more degrees away from that? So they're eroding more towards the south than they are to the north, true? Okay, so which south? Are they eroding to the left or to the right? Next one down. And if you want to go to these spots in Google Earth, I've put the latitude and longitude here so that you can go find it yourself if you want. And be able to rotate it and really take a look at this, okay? So number 2 is about headward erosion in Montrose, Colorado. In which direction are the streams experiencing headward erosion? Again, notice the orientation of the N on the upper right circle. Okay, so N is now off to the right somewhere, which means south is to the upper left. Okay. So what direction do these streams, these dark lines are the streams, the stream beds. This is lower. Note you can see the agricultural fields down below here on the bottom of the picture. And this is all hilly terrain, pretty steep hilly terrain, basically to the south on this picture, south and southwest. So the streams are draining the opposite direction, true? They're draining to the northeast because they're draining this way. Streams can develop a variety of drainage patterns depending on the rock type and structure of the rocks that underlies them. So I've got a bunch of pictures from the real world here. Number 3, what is the stream drainage pattern exhibited here? Meandering streams are flowing to the northeast and their confluence is indicated by the red arrow. So here is a ridge line. Here is a ridge line. There's a valley in between here. Here's a stream going down here, going whatever town this is. Here's a meander. Look at those. Look at the meanders. Ooh, huge meanders here. And then it comes over here and they converge here. But the reason, these ridges they constrain the streams in between the ridges. And then eventually, the ridges end of bigger river has eroded down through that bigger ridge, probably as the ridge was exhumed by erosion. So what kind is this? Trellis, rectangular, radial, or dendritic? This picture in number 4 is of Mount Rainier. You can see the white lines coming off. This one's actually, the brown is actually old lahars, which are volcanic mud flows that have filled in the stream channels a ways away from the river. Okay, so they're all kind of radiating out from a single point. Which kind is this? Trellis, rectangular, radial, or dendritic? Number 5, what is the stream drainage pattern exhibited here? Well, here's the main stream, and it's meandering, and then it's got these branching type of structures of all the tributaries branching away from the main stream. And that's the key to which one this is. Is it trellis, rectangular, radial, or dendritic? Now let's look at some meandering river features. This red arc, I've drawn that on top of part of the old path of the Mississippi River. Here's the modern Mississippi that actually has a cutoff with a small, it's split. So there's like an island out there. This is the cutoff. This is the old point bar that got cut off. Okay. Now, way back, the river used to flow here. So notice the nested semicircles of patterns. So this feature here was built on the inside of a meander loop. Inside of a meander loop. This feature is called is it a cut bank, a point bar, or a thalweg? Because these nested patterns here are from sedimentation. Periodic continuing sedimentation, okay? Number 7, the outside of this curve in the river, okay? So the outer part of this curve, when it was going around the red curve, when the river was going around the red curve in the above picture, would have been, choose anything that applies here, okay? Was it a feature that we call a cut bank? Was it where the water of the river would have its greatest velocity? Or was it where the water of the river would have its least velocity? Was it where the greatest amount of erosion would occur? Or was it where the least amount of erosion would occur? So on the outside of that curve, when the water of the river was going around that curve. Continuing down into number 8, the brown, greenish brown semicircular curve feature seen here, which I've somewhat outlined in yellow, is okay, so here we go. Choose any that apply, all that apply. Is it the remnant of an oxbow lake? Is it almost to the point of being a filled former channel? Is it almost completely silted in? And is it cut off from the flow of water of the major river nearby, which is this? That's the flow of water of the major river nearby. And you could tell by the farmland and the periodic white blocks, those are houses and barns. So you get an idea about how big this thing is. And then the last question on here. I think I have to change that date. Judging by the character of the watery landscape here, near Natchitoches, Louisiana. Okay, and I've pointed to the water sitting on the landscape here with these red arrows. And the apparently full reservoir to the west of town. So here's a reservoir west of the town of Natchitoches. Okay, what occurred to make it appear so watery over here? There's obviously fields over here, agricultural fields. So did they over irrigate the fields? Was it flooding due to a dam failing? Because reservoirs have dams. So did the reservoir, did the dam fail and flood over there? Or was it flooding due to heavy rainfall? And you can actually go and watch a YouTube video of a little bit less than 2 minutes of drone footage that someone took from March 10th of 2016. And this picture here was dated at March 24th of 2016. So 2 weeks later is when this Google Earth picture is from, whereas this drone footage is from 2 weeks previous to the picture, okay? So you'll have the same deadline for this part as you will have for the 3 documents you have to put in for part 1. And I'm gonna pause it. So I wanted to go get the schedule so because I have to change this date because the window to post for submission of answers for this lab is Thursday the 18th. I didn't update my date on the bottom of this from last year. And then it'll be due Wednesday the 24th, which is Thanksgiving evening, yes, but it's the 24th, not the 25th this year, okay? I'll make sure that I change that. So by the time maybe you look at it, it will be indeed changed. All right, there it is. So this recording is done and I'll get these posted as quickly as I can.